It's not unusual for older buildings to possess incomplete or outdated fire alarm systems, particularly if they've undergone remodeling or renovations over the years. Building codes and fire safety regulations evolve, and older structures might not adhere to contemporary standards. In a given scenario, the electrical inspector seemingly mandates the installation of a horn/strobe within the bathroom because the remodeled building will necessitate a comprehensive fire alarm system. This stems from the remodel being classified as a substantial alteration to the building, hence the necessity to comply with current fire safety codes. The precise code stipulations for fire alarm systems in bathrooms differ contingent upon the jurisdiction. However, bathrooms generally mandate audible and visual fire alarms integrated with the building's fire alarm system. This guarantees that occupants receive fire alerts even within private spaces like bathrooms. When remodeling an older building, several factors determine the extent of fire alarm upgrades required. Firstly, the scope of the remodel significantly influences code compliance. A minor cosmetic upgrade might not trigger extensive fire alarm enhancements, whereas a major renovation, such as adding a new wing or significantly altering the building's layout, invariably necessitates a complete system evaluation and upgrade. Secondly, changes in occupancy also play a role. If the building's usage shifts, for instance, from a retail space to an office complex or residential units, fire alarm requirements change. Different occupancy types have varying safety standards, impacting the system's design and functionality. Thirdly, alterations to the building's structure itself can mandate fire alarm upgrades. Installing new walls, removing existing ones, or modifying the building's height or area might trigger code requirements for enhanced fire protection. Fourthly, local building codes and fire safety regulations are paramount. These codes evolve regularly, mandating upgrades even if the existing system met previous standards. It's crucial to consult the latest edition of the applicable building code and any local amendments or interpretations. Fifthly, the age of the existing fire alarm system factors into the upgrade decision. Systems nearing their end of life or lacking modern features might require replacement regardless of the remodel scope. Modern systems offer advanced capabilities like voice evacuation, remote monitoring, and integration with other building systems, enhancing overall safety. When planning a remodel, a comprehensive fire alarm system evaluation is paramount. This evaluation should involve a qualified fire protection engineer or a certified fire alarm technician. The evaluation encompasses several key aspects. Firstly, a thorough review of the existing system's documentation, including as-built drawings, equipment specifications, and maintenance records, is essential. Secondly, a physical inspection of the system components such as control panels, initiating devices, notification appliances, and wiring is necessary to assess their condition and functionality. Thirdly, verification of the system's compliance with the current applicable codes and standards, including the National Fire Protection Association 72, the International Building Code, and any local amendments is required. Fourthly, identification of any deficiencies in the existing system, such as outdated equipment, inadequate coverage, or non-compliance with codes is crucial. Fifthly, development of a detailed upgrade plan outlining the necessary modifications, additions, or replacements to ensure full compliance with current regulations. The upgrade plan should encompass several critical elements. Firstly, specifying the new fire alarm system components, including control panels, initiating devices, notification appliances, and wiring, ensuring they meet the latest UL standards and are compatible with the existing system if applicable. Secondly, designing the system layout, ensuring adequate coverage of all areas within the building, including bathrooms, stairwells, corridors, and any newly remodeled spaces. Thirdly, determining the appropriate notification appliance placement and audibility levels, adhering to the Americans with Disabilities Act requirements for accessible notification in areas serving individuals with disabilities. Fourthly, integrating the fire alarm system with other building systems such as the HVAC system, elevator controls, and door locking mechanisms to enhance overall fire protection and facilitate safe evacuation. Fifthly, conducting thorough testing and commissioning of the upgraded system, verifying its proper operation and compliance with all applicable codes and standards. When selecting a fire alarm contractor, consider their qualifications, experience, and reputation. Firstly, verify that the contractor holds the necessary licenses and certifications to design, install, and maintain fire alarm systems in the relevant jurisdiction. Secondly, assess the contractor's experience in similar projects, reviewing their portfolio and client testimonials to gauge their expertise and reliability. Thirdly, check the contractor's insurance coverage and bonding to protect against potential liabilities or damages during the project. Fourthly, obtain multiple bids from qualified contractors, comparing their pricing, scope of work, and proposed equipment to ensure a competitive and comprehensive offer. Fifthly, request references from previous clients, contacting them to inquire about their experience with the contractor's workmanship, communication, and adherence to schedules. During the fire alarm system installation, several precautions are necessary to ensure safety and minimize disruptions. Firstly, proper planning and coordination are crucial, collaborating with the contractor to develop a detailed schedule and minimize impact on the building's occupants and operations. Secondly, ensuring that all work areas are properly barricaded and marked with appropriate safety signage to prevent unauthorized access and potential hazards. Thirdly, implementing dust control measures, such as using plastic sheeting and HEPA filters to minimize the spread of dust and debris during demolition and installation activities. Fourthly, providing temporary fire protection measures, such as portable fire extinguishers and smoke detectors, in areas where the existing fire alarm system is temporarily disabled. Fifthly, conducting regular inspections of the work site to identify and address any potential safety hazards or code violations. After completing the fire alarm system upgrade, thorough testing and commissioning are essential to verify its proper operation and compliance with all applicable codes and standards. Firstly, conducting a complete system test, activating all initiating devices and notification appliances to ensure they function correctly and provide adequate coverage. Secondly, verifying the system's communication with the monitoring company, confirming that alarms are transmitted promptly and accurately. Thirdly, conducting a battery backup test, simulating a power outage to verify that the system operates correctly on battery power for the required duration. Fourthly, performing a sensitivity test on all smoke detectors, ensuring they respond appropriately to varying levels of smoke. Fifthly, providing comprehensive training to the building staff on the operation of the fire alarm system, including how to respond to alarms, reset the system, and perform routine maintenance tasks. Documentation is a critical aspect of fire alarm system compliance. Firstly, maintaining accurate and up-to-date records of the system's design, installation, testing, and maintenance. Secondly, keeping copies of all permits, approvals, and inspection reports related to the fire alarm system. Thirdly, retaining documentation on all system components, including manufacturer specifications, wiring diagrams, and programming information. Fourthly, developing and implementing a regular maintenance schedule, documenting all inspections, tests, and repairs performed on the system. Fifthly, providing clear and concise operating instructions for the fire alarm system, making them readily accessible to building occupants and emergency responders. Ongoing maintenance and inspection are essential to ensure the fire alarm system's continued reliability and effectiveness. Firstly, conducting regular visual inspections of the system components, checking for any signs of damage, corrosion, or tampering. Secondly, testing all initiating devices and notification appliances on a periodic basis, following the manufacturer's recommendations and applicable codes. Thirdly, maintaining the system's batteries in good condition, replacing them as needed to ensure reliable backup power. Fourthly, cleaning smoke detectors regularly, removing any dust or debris that could affect their sensitivity. Fifthly, performing annual inspections and certifications by a qualified fire alarm technician, verifying the system's compliance with all applicable codes and standards. If the building is situated within an area governed by a fire marshal's office, contacting them can furnish guidance on the specific code prerequisites for fire alarm systems and bathrooms. It's equally important to consult with a certified fire alarm contractor to guarantee the system's design and installation align with the applicable codes and standards. Audible fire alarms typically generate a sound pressure level of at least 75 decibels at the pillow in sleeping areas to awaken occupants. Visual alarms, such as strobes, must have a flash rate between 1 Hz and 2 Hz to avoid triggering seizures in individuals with photosensitive epilepsy. The Americans with Disabilities Act mandates accessible notification in areas serving individuals with disabilities. This includes providing both audible and visual alarms in restrooms, sleeping rooms, and other accessible spaces. Fire alarm systems should be designed to minimize false alarms, which can disrupt building operations and erode trust in the system. This can be achieved by using addressable fire alarm systems, which pinpoint the exact location of an alarm, and by implementing proper maintenance and testing procedures. Consider the specific needs of the building's occupants when designing the fire alarm system. For example, in buildings with a high proportion of elderly residents, the system should be designed to provide clear and concise voice evacuation messages. In buildings with a high proportion of hearing-impaired residents, the system should include visual alarms in all common areas. The National Fire Protection Association 72 provides comprehensive guidance on the design, installation, inspection, testing, and maintenance of fire alarm systems. Local building codes may have additional requirements that must be followed. It is important to consult with a qualified fire protection engineer or a certified fire alarm technician to ensure that the fire alarm system meets all applicable codes and standards. A properly designed and maintained fire alarm system can save lives and protect property. It is an essential component of any building's fire safety plan. Understanding the role of a fire alarm control panel is essential. The fire alarm control panel, often referred to as the FAC, serves as the central hub of the fire alarm system. Firstly, it receives signals from initiating devices such as smoke detectors, heat detectors, and manual pull stations. Secondly, it processes these signals to determine the appropriate response, such as activating notification appliances and transmitting an alarm signal to the monitoring company. Thirdly, it supervises the system's wiring and components, detecting any faults or malfunctions. Fourthly, it provides a user interface for system operation and maintenance, allowing authorized personnel to view system status, silence alarms, and perform other functions. Fifthly, it communicates with other building systems such as the HVAC system, elevator controls, and door locking mechanisms to coordinate fire safety responses. Addressable fire alarm systems offer several advantages over conventional systems. Firstly, they provide precise location information for each initiating device, allowing firefighters to quickly locate the source of the alarm. Secondly, they offer enhanced supervision capabilities, detecting faults and malfunctions with greater accuracy. Thirdly, they enable more sophisticated programming and control functions, allowing for customized responses to different alarm conditions. Fourthly, they facilitate easier maintenance and troubleshooting, simplifying the process of identifying and resolving system problems. Fifthly, they support advanced features such as voice evacuation and remote monitoring, enhancing overall fire safety. When integrating the fire alarm system with other building systems, consider the following factors. Firstly, the compatibility of the different systems, ensuring they can communicate effectively and exchange information. Secondly, the coordination of fire safety responses, ensuring that the different systems work together to protect occupants and property. Thirdly, the prioritization of fire alarm signals, ensuring that fire alarms override other system functions in the event of a fire. Fourthly, the security of the integrated systems, protecting against unauthorized access and manipulation. Fifthly, the testing and maintenance of the integrated systems, verifying their proper operation and coordination on a regular basis. Voice evacuation systems provide clear and concise instructions to building occupants during a fire emergency. Firstly, they can provide pre-recorded messages in multiple languages, ensuring that all occupants understand the evacuation instructions. Secondly, they can provide live voice announcements, allowing firefighters to communicate directly with occupants and provide updates on the situation. Thirdly, it can be used to direct occupants to safe evacuation routes, avoiding areas of danger. Fourthly, it can be integrated with the fire alarm system to automatically activate upon detection of a fire. Fifthly, they can be used to provide reassurance to occupants, reducing panic and promoting orderly evacuation. Emergency voice alarm communication systems, often referred to as EVACs, are designed to provide clear and intelligible voice communications during fire emergencies. They consist of several key components. Firstly, a central control unit, which manages the system's operation and provides a user interface for authorized personnel. Secondly, amplifiers, which boost the audio signal to ensure adequate audibility throughout the building. Thirdly, speakers, which distribute the voice messages to occupants. Fourthly, microphones, which allow firefighters to make live announcements. Fifthly, a backup power supply, which ensures that the system continues to operate during a power outage. The design of an EVACs must consider several factors. Firstly, the building's acoustics, ensuring that voice messages are clear and intelligible in all areas. Secondly, the ambient noise levels, selecting speakers with sufficient output to overcome background noise. Thirdly, the distribution of speakers, providing adequate coverage throughout the building. Fourthly, the location of microphones, ensuring that firefighters can easily communicate with occupants. Fifthly, the integration with the fire alarm system, ensuring that the EVACs automatically activates upon detection of a fire. Fire alarm system maintenance should include the testing of initiating devices such as smoke detectors and heat detectors. Smoke detector testing typically involves using a calibrated aerosol smoke generator to introduce simulated smoke into the detector's sensing chamber. The detector should activate within the specified time and transmit an alarm signal to the fire alarm control panel. Heat detector testing involves using a heat gun to apply a controlled amount of heat to the detector's sensing element. The detector should activate within the specified time and transmit an alarm signal to the fire alarm control panel. Manual pulse station testing involves activating the pulse station and verifying that it transmits an alarm signal to the fire alarm control panel. Notification appliance testing involves activating the fire alarm system and verifying that all audible and visual alarms operate correctly. Audible alarms should produce a sound pressure level of at least 75 decibels at the pillow and sleeping areas and at least 65 decibels in other areas. Visual alarms, such as strobes, should have a flash rate between 1 Hz and 2 Hz. Battery backup testing involves simulating a power outage and verifying that the fire alarm system operates correctly on battery power for the required duration. The battery backup system should be capable of powering the fire alarm system for at least 24 hours in standby mode followed by 5 minutes in alarm mode. Wiring and connections should be inspected to ensure they are in good condition and properly connected. All wiring should be securely fastened and protected from damage. Connections should be tight and free of corrosion. Fire alarm control panel should be inspected to ensure it is clean, properly labeled, and functioning correctly. All indicators and controls should be clearly labeled and easy to understand. The fire alarm control panel should be free of dust, dirt, and debris. Documentation should be reviewed to ensure it is accurate and up to date. All system drawings, manuals, and test reports should be readily available and easily accessible. The documentation should be reviewed on a regular basis to ensure it is accurate and complete. Understanding the different types of fire detectors is essential for designing an effective fire alarm system. Smoke detectors are designed to detect the presence of smoke, which is an early indicator of fire. There are 2 main types of smoke detectors: photoelectric and ionization. Photoelectric smoke detectors use a light beam and a photosensor to detect smoke. When smoke enters the detector, it scatters the light beam, causing the photosensor to activate. Ionization smoke detectors use a small amount of radioactive material to ionize the air in the detector. When smoke enters the detector, it disrupts the ionization process, causing the detector to activate. Heat detectors are designed to detect the presence of heat, which is another indicator of fire. There are 2 main types of heat detectors: fixed temperature and rate of rise. Fixed temperature heat detectors activate when the temperature reaches a predetermined level. Rate of rise heat detectors activate when the temperature rises rapidly. Flame detectors are designed to detect the presence of flames, which are a direct indicator of fire. Flame detectors use infrared or ultraviolet sensors to detect the light emitted by flames. Multi-sensor detectors combine multiple sensing technologies to provide enhanced fire detection capabilities. For example, a multi-sensor detector may combine smoke and heat sensors to provide more reliable fire detection and reduce the risk of false alarms. Beam detectors are used to protect large open areas such as warehouses and auditoriums. Beam detectors consist of a transmitter and a receiver. The transmitter emits a beam of light that is directed at the receiver. If smoke enters the beam path, it will attenuate the light, causing the receiver to activate. Air sampling detectors are used to detect very small amounts of smoke. Air sampling detectors draw air from the protected area and pass it through a sophisticated detection chamber. Air sampling detectors are often used in clean rooms and other sensitive environments. Duct detectors are used to detect smoke in air ducts. Duct detectors are typically installed in the return air ducts of HVAC systems. When smoke is detected, the duct detector will activate the fire alarm system and shut down the HVAC system to prevent the spread of smoke. The specific code requirements for fire alarm systems vary depending on the jurisdiction. It is important to consult with the local building code and fire safety regulations to ensure that the fire alarm system meets all applicable requirements. The National Fire Protection Association 72 provides comprehensive guidance on the design, installation, inspection, testing, and maintenance of fire alarm systems. The International Building Code also contains requirements for fire alarm systems. Local building codes may have additional requirements that must be followed. It is important to consult with a qualified fire protection engineer or a certified fire alarm technician to ensure that the fire alarm system meets all applicable codes and standards. Understanding the Americans with Disabilities Act requirements for fire alarm systems is important. The Americans with Disabilities Act requires that fire alarm systems provide accessible notification for individuals with disabilities. This includes providing both audible and visual alarms in restrooms, sleeping rooms, and other accessible spaces. Audible alarms must produce a sound pressure level of at least 75 decibels at the pillow and sleeping areas and at least 65 decibels in other areas. Visual alarms, such as strobes, must have a flash rate between 1 Hz and 2 Hz. The Americans with Disabilities Act also requires that fire alarm systems provide clear and concise voice evacuation messages. Voice evacuation messages should be pre-recorded and available in multiple languages. Fire alarm systems should be designed to minimize false alarms. False alarms can disrupt building operations and erode trust in the system. There are a number of things that can be done to minimize false alarms. Use addressable fire alarm systems, which pinpoint the exact location of an alarm. Implement proper maintenance and testing procedures. Educate building occupants about the fire alarm system and how to avoid causing false alarms. Install smoke detectors in appropriate locations. Avoid installing smoke detectors in areas where they are likely to be triggered by cooking smoke or steam. Consider the specific needs of the building's occupants when designing the fire alarm system. For example, in buildings with a high proportion of elderly residents, the system should be designed to provide clear and concise voice evacuation messages. In buildings with a high proportion of hearing-impaired residents, the system should include visual alarms in all common areas. A properly designed and maintained fire alarm system can save lives and protect property. It is an essential component of any building's fire safety plan.